Welcome to Science Access. In today's class, I'll be taking Boyle's Law Part 2, and I'll actually be taking calculation questions and answer on Boyle's Law. All right, so let's take a look at this question. But before we continue, please kindly watch the part 1 of this video so that you understand it better. Assume a gas occupy 730 milliliter at ground level. Now, the gas was transported to an elevation of 10 kilometers where the pressure is this. At this altitude, the gas occupies a volume of 1280 milliliter. If the temperature is constant, what was the ground level pressure? Now, our Boyle's law, remember, Boyle's law states that pressure is inversely proportional to volume. So let's now introduce the constant sign. We now have P is equals to K all over V. Remember, to change this sign of proportionality to equal to sign, you have to introduce the constant. So let's now cross multiply. We use this to multiply this and use this to multiply. You now have K is equals to PV. So in most questions, you'll be given two pressure and two volume. So in that case, how do you solve it? You now introduce this P1 V1 equals to P2 V2. So this is how we get this formula. So this is the formula we will now be using to calculate. Now, remember, P1 is initial pressure. That's the first pressure. V1 is initial volume. P2 is the final pressure. And V2 is actually the final volume. So let's go back to the question and check for the initial volume. A gas occupies a volume of this. So this is actually the initial volume. So the initial volume is 730 V1. Now, did they give us the initial pressure? No. Okay. So we now have P1, we don't, is unknown. It was now transported to a height of this. So the pressure at that height, where the pressure is 0.7. So the P2 is 0.7. All right. Now, take note, at this height, the volume at this height, at this altitude, the gas occupies a volume of 1280. So the V2, which is our final volume, is 1280. You are now asked, remember the temperature is constant, you are now asked what was the ground level pressure, the pressure at the ground level, which is P1. That's what we are looking for. Simple. We apply this formula. Now, let's now make the P1 the subject of formula. I want to make P1 to stay on its own. In this case, we'll now divide both sides by V1. So I want to remove V1 from here. So how do I do that? I'll use V1 to divide this place. I'll use V1 to divide this place. Now, if you want to do that, this one will now cancel out this. So we'll now have P1 is equals to P2 V2 all over V1. So this is the formula that we're going to use to calculate our question. So what is our P2? P2 is 0.7. Put your 0.7 here. What is our V2? Our V2 is 1280 times 1280 all over. What is our V1? Our V1 here is 730. So we have 730. You now use this to multiply this. You have this all over 730. Now if you carry out your division, and that is your answer is 1.22 atmosphere. So let's take question number 2. Let's take question number 2. A gas occupies 1 liter at 1 atmosphere. Remember, a gas is occupying 1 liter. This is the volume at 1 atmosphere. If the volume is halved, you are reducing the volume by half. Calculate the pressure, assuming the temperature is constant. So remember our formula in the first question. Our formula is P1 V1 equals to P2 V2, and our P1 is the initial pressure. V1 is the initial volume, P2 is the final pressure, and V2 is the final volume. So our P1, the gas occupies 1 liter. So 1 liter is our, all right, our P1 is actually 1 atmosphere. 1 atmosphere, this is the pressure. While our V1 is actually 1 liter. Remember, liter is volume and atmosphere is for pressure. We have various units for pressure and various units for volume. All right. Now, what is our P2? They are asking you to calculate the pressure. So our P2 is unknown. And what is our V2? If the volume is halved. So it simply means that our V2 is 1 all over 2. That's half. Another way you can put it is 0.5. So if the volume is half, so it's either 1 over 2 or 0.5. So let's now calculate for the P2. Using this formula, to make P2 the subject of formula, we can divide both sides by. We want to make this P2 the subject of formula because we are looking for this P2. So we can divide both sides by V2 so that V2 will leave this place, leaving this P2 alone in that side. So this will cancel out this. We now have this P2 here is equal to P1, V1 all over V2. So we can also put it this way. P is equal to P2 is equal to P1, V1 all over V2. What is P1? Is 1. We know that it's 1 atmosphere. What is V1? It's also 1 liter all over. What is V2? V2 is 0.5. 0.5. So if you use 1 to multiply 1, what will you have? You have 1 all over 0.5. And if you carry out the division, you have 2 atmospheres. So now you realize that as this volume actually decreased, the pressure actually increased. So it's actually obeying Boyle's law. Now, let's also use, you remember I used 0.5 to actually calculate. Let's use 1 all over 2. It's the same thing actually. So we can just put it this way. Remember this up is like 1. Okay, I can decide to put this all over 1. Now this down is divide. This, remember this place is divide. Divide. Here, instead of 0.5, let's put divide 1 all over 2. Now, remember that mathematics rule where if you want to change this divide to multiplication, you turn this one. So we now have 1 all over 1 times 2 all over 1. This is now the inverse because this division sign have changed to what? Multiplication sign. So 1 times 1 is, 1 times 2 is what? 2 all over. 1 times 1 is 1. And our final answer, if you use 1 to divide 2, you still have 2. So 2 atmospheres. So it's still the same thing. You can do that. This method is good when you are using calculator, but if you are not using calculator, you can just use this method to calculate your work. All right. And the last one is an ideal gas. An ideal gas occupy a 3.0 liter flask at this. This is the. Remember, I mentioned of the fact that we have many units for pressure. We have this unit atmosphere, we have torr, we have Newton meter square and all that. So an ideal gas occupy a volume of 3.0 liter flask at 760 torr and is allowed to expand. Now the volume is expanding to a volume of 9,000 milliliter. Calculate the final pressure. Now, as usual, this is our formula. This is the initial pressure, the initial volume, final pressure, and the final volume. So what is our P1? The initial pressure. That is it. What is our V1? This is it. What is our P2? Now, our P2 is not given. That's what they asked us to calculate for the final pressure. And what is our V2? Our V2 is 9,000 milliliter. Now, remember this one, this unit is different from this unit. Here it was given as 3 liter. Here is given as 9,000 milliliter. So in order to convert milliliter to liter, you divide it by 1,000. So if you divide 9,000 by 1,000, you have 9 liters. So that's the conversion. Let's now make P2 the subject of formula. Remember how I made P2 the subject of formula here? I wrote down the formula and I divide both sides. Because this, remember, this P2 that we are looking for, we want to make this P2 to stay alone. So I'll have to look for a way to remove this V2. That's the reason why I'm dividing both sides by 2. V2, sorry. So I'll now divide this side by V2 and this side by V2. So if this now cancel this P2 is now actually alone. This P2 is now actually alone. So we now have P2 is equals to P1, V1 all over V2. So we can also make it the inverse. P2 is now P1, V1 all over V2. What is our P1? Our P1 is 760. Our V1 is 3 times 3. Then our V2 is 9. 9 here. So if you use this to multiply this, you have this all over 9. Then our final answer, if you use 9 to divide this, you now have 253.3 torr. as your final pressure, which is the P2. Now, a question is being displayed on the board. Take this as assignment and solve the question. Send your answer to the email being displayed on the board, or you can put your answer in the comment section. Thank you for watching.